Morning, guys. Like Jacques said, thanks to our sponsors. End of week one. So for the guys that haven't chewed off their wrists, or the guys that are out there, keep it safe. This morning's tech talk around shuttle valves. Let's start off by saying that when we're looking at shuttle valves or isolating valves, it is a water fitting that's used to shut off and isolate a part of a water installation from the main installation or the mains. And the term includes ball valves, gate valves, stopcocks, or any other type of shut-off valve arrangement. We're going to concentrate on the three that has been pointed out there. So let's get started. I just want to clean this up and get my hand out here. There we go. Okay. So we start off by looking at the definition of a ball valve or a ball cock. It is a valve that can regulate flow by means of a ball with a hole through it so it can be sealed by rotating through 90 degrees. We all use them, and the special thanks to my friends that I do have, or the few that I do have. There's a section or a cutaway of what it looks like. So in an open position, you'll find that the side of the ball actually lets the water through that hole, and in the shut position, then you'll find that it actually seals off very, very nicely. One of the better plumbing inventions, watertight or drop tight. So you shut the water off, there's no hassles around getting work done. Gate valve. Sorry, I just want to add something because we're going to look at that shortly. You'll see that there is a national standard for a ball valve, and if it does not comply with that standard, please do not use. You'll see shortly. Then there's a gate valve. It's a full bore isolating using a sluice or a gate to slide up and down in that area that's indicated. Let me just get this out here. You'll see it's beveled. So by turning the spindle, that gate then settles down into that slot or that groove that was provided there. Fully opening or shutting off water supply. So you'll see 776 or SAN 776 would be for the copper alloy ones, and the bigger ones, the gate valves or the cast iron and the silicon, the resilient seal ones, you'll find that it's the same principle there. You can see it's got the gate and it slides up and down. Important to note, it says here fully opening or shutting off water. The third option you've got is a normal stopcock. It's been around forever. SANS 226, so it falls under the same category than a normal screw down tap. It's a valve that can regulate or prevent flow by means of incorporating an orifice that can be sealed off with a washer and a plate. So the washer and the plate we're all familiar with. Basically, water comes in through the orifice and out the other side there. So like I said, it's been around forever. And the reason I'm pointing out these standards, or the reason I pointed out these standards, is that there are, all that glitters is not gold. You will find shuttle valves, ball cocks, stop cocks, gate valves, anything out there that is not necessarily compliant. And you'll see what ends up happening is that they do fail, that they do break apart. So we're going to give them a big thumbs down, and we're going to say we're not worried about those. We'll rather use the proper ones. If you consider the importance of an isolating valve when you're doing maintenance, your client's already in a panic, or there's a geyser that burst, so you get to site, you need to isolate water because that'll calm them down. It'll give you the opportunity to get working on the problem. So instead of having water squirting all over the place, you just walk up to the isolating valve and you close the water and you can start working. Everybody's happy. You do not want to have your isolating valve fail on you when you need it most. So into the standards, SANS 10252 Part 1 says, unless otherwise required or provided, 6132 does not apply. A specific isolating valve shall be provided. So let's stop there for a second and we go straight to 6132, which refers to an isolating valve shall not be provided between any pressure reducing valve and a water heater if such a pressure reducing valve incorporates an expansion relief or vacuum relief device intended to protect such a water heater. So before we look at the places or the actual applications for isolating valves, let's just quickly have a look at what 6132 is trying to say here. Basically what it does, it repeats what is said in SANS 10254 that says an isolating valve shall not be provided between a pressure reducing valve and the heater. Vacuum control, it says in closed systems and in valve operated vented systems, vacuum control valves shall be installed on both hot and cold water pipes to and from the water heater to ensure that both lines and the water heater is vented. So it's not only the actual geyser that needs to be vented, but that whole line, whether it be hot or cold, actually needs to be protected as well, or vented in that, or for that matter as well. Expansion control. When an expansion control valve is installed on the cold water side of a water heater, it shall be installed downstream of any isolating valve, gate valve, non-return valve, or any flow control device. So as you can see here, these gentlemen, the slight slip up or slight brain freeze, you'll find that that would not be acceptable in anyone's book. So there's no isolating valve, especially the stopcock is a one-way flow direction as well, so that you can't have any of that. And at the same time, when you look at, that's as close as you can get to shutting everything off, so we can't have that. And here you can see flow control non-return between the PRV and the actual cylinder, so we can't have any of that. So instead of just being all negative about this, you can actually have a shutoff valve closer to your cylinder if it is done properly, and you provide a separate expansion relief between the valve and the actual cylinder. So in this case, to this gentleman that did this job, very well done. That is as per the book as you can get it. So we get back to isolating valves. Unless otherwise required, a isolating valve shall be provided in the case of any water meter installed outside the boundary of the premises if the service pipe or in the service pipe at a point not exceeding 1.5 meters. So here you can see we've got the boundary, we've got the water meter installed by the local authority. The standard says within 1.5 meters on your client side, you shall provide an isolating valve. In the case of any water meter installed inside the boundary at a suitable point on the consumer side of the water meter. So same thing applies. The water meter is left on the inside of your client's property, and you'll find that it says at any suitable point, which is in most cases as close to the water meter as possible, because that's where your supply goes underground, or that's where you pick up the supply from the local authority. There's no sense in having a shutoff valve 20 meters further stuck in the lawn or hidden somewhere else. Most people, when you end up getting to site, you find the water meter, and that's where the shutoff point is. Next point, where a pipe enters any building or any portion of a building in separate occupation, that's straightforward. I mean, you have got various occupants, so each one of them need to treat their water supply differently, or you need to maintain or work on a specific unit or a portion of a building. You don't want to shut the whole development or the whole complex down just to work on a ball valve or work on your client's property. D says any branch pipe serving a flushing cistern or next to a cistern. You'll find the older ones, you'll find that the plumbing's on the outside wall. There'll be a stopcock on there. Pipe comes through the wall connected to the float valve. So that's pretty much straightforward. On any branch pipe that serves an automatic flush valve or a flushing valve, unless that valve incorporates its own isolating valves. So we've all done maintenance, all gotten to a shopping center or a public building. There's nothing better walking into a block of toilets or urinals for that matter, and you simply close that ballcock on the unit or on the flush master. You don't have to go looking for keys, getting into plumbing ducts and that. So just as a matter of interest, another cut through there, you can see that valve there, or that shut down or shut off on this here. So you can change diaphragm, you can change the push button. The thing flushes too long, anything that needs to happen on that valve can then happen there. But if you do not buy or you don't have the proper one, or let's call it the better one, you need to install an isolating valve on that branch that actually serves that flush master. on each side of and next to any backflow preventer or any combination of backflow preventer and pressure reducing valves. Now guys, these things start from as small as 15, 22 mil right up to whatever the municipality uses on their systems and your fire guys. And so the reason for that is you'll find that it says on each side and next to. So if it's on each side of this here, the whole point around backflow preventers that you have to service them or replace them or clean them up every 12 months or annually. And the only way you're going to do that without upsetting the whole system or replacing or fixing any of these is to actually have the shutoffs either side of that valve. It's not a nice to have or an optional. It shall be installed like that. So just a point, if you are going to be installing backflow preventers, make sure that you do have shutoffs on either side of them. On each side and next to any pressure reducing valve of nominal inlet diameter exceeding 25, it only makes sense. Most of them you'll find have got cap and nut connectors in any event, so you do have shutoffs either side. Bigger than 25 could be anything, so we're not going to waste water. We're not going to end up with a problem where you need to drain a whole system just to work on a PRV, or then rather have your work done according to the book and make sure that it actually complies. It's easy enough to install these things, so I fail to see how you cannot have isolating valves on stuff that would actually save you time and money while you're on the go. On the upstream side of any pressure reducing valve not exceeding 25, so the ones that are normal residential, you'll find that on the upstream side, you need to be able to shut that off, service it, replace cartridge, disconnect or shut down the water, but on the upstream side of that unit that you'd be installing. Now, this is one I'd like to just spend a minute on. It reads straightforward. It says, in such a position, it should become necessary to drain any pipe. The total length of the pipe that has to be drained between isolating valves does not exceed 30 meters. 30 meters is quite a length of pipe. You'll find that we're not talking about a normal house where the water meter is in the front and you run the pipe towards the back of the house, or basically to the where all the plumbing is. If you think about looking at this layout here, if you think about these units here, most of these sectional title units, you'll find have got either in the public space or in that common space in the roadways or on the verge next to the roadways, they've got their internal reticulation and they've got their normal shutoff as per inside the boundary at each of these individual units. They've got their own shutoffs on each of these units. Then the standard says not exceeding 30 meters. So you need to look at that whole reticulation. Obviously, it would be nice if it was done from the beginning, but if you're doing maintenance, we'll have a look at that just now. The whole idea is that if it does not exceed 30 meters, that means that you could have these things isolated in portions, not exceeding 30 meters. If you take that valve and the next valve, or that valve and the next one, we need to have less than 30 meters. Now, if you think about it, all the places that you do maintenance, or all the places that you do busy, or that you do keep busy and that you service as a client, why would you want that 30 meters, or why would you want that 30-meter rule in place? It's not only water conservation. I mean, you don't want to drain. If it's a complex and there are hydrants in there, you're probably looking at a hydrant 75 or 110 millimeter diameter pipe. And now there's a problem somewhere and you need to drain 110 mil pipe to get to a minor leak on one of the branches. It could even be a saddle or anything gone wrong. So as far as water conservation is concerned, that is a motivation, a genuine one. Controlled shutdown. I mean, if you need to work on one unit or one or two units, or there's a burst pipe here, you could always just close that one half of the reticulation. While you're on that subject and you're talking to your clients about this 30 meters and controlled shutdowns and all the other fittings, you might look at it at a job creation or providing an informed service to your client. If there's any sloped sites, in other words, you have got huge gradients where there could be stuff accumulating at the bottom of your main. If there's a burst pipe somewhere from the municipal or internal side, or anything gets into the lines, it might require a scour valve at the bottom end of it to get all the nasties out there. You might require strainers on the lower units. If you look at that 30-meter rule and you look at what the actual intention is of it, then you could actually talk to your clients. You could actually do a bit of research or do a bit of homework and make sure that the thing complies, or that you get your client's installation to comply and improve on that system. Even if it's been around forever, things change. So we can only keep up with the times and see that we provide a service that is not unique, but by a professional. And we do the extra bit. That's the difference between someone that will come along and just service a ball valve and someone would actually look at the whole plumbing reticulation. Point J says, in the case of a storage tank, on the inlet pipe next to and upstream of the valve controlling the supply. So if we're going upstream of the valve controlling the supply, would give you a shutoff on the inlet side, but at the same time on the outlet pipe from the storage tank. So we also need one on the outlet. And this is a different arrangement for a pumping line. But the point is that when you're looking at something in storage, like the cistern, like the geyser, like this cold water storage tank, anything that stores water, you need to be able to isolate. If you need to work on this side, you don't want to drain the whole tank, so you have to have on the outlet side. If you need to work on the valve supplying or the valve controlling the supply, you need to be able to isolate. So these are all in the standards, and these, if you remember, it started off, it said it shall have that. So it's not a nice to have, it's a requirement when you're doing proper plumbing to make sure that it complies. Valves, the following valves shall be deemed acceptable: copper alloy gate valves that comply with SAN 776 and 1857. So copper alloy, there's your brass valves, as relevant for isolating purposes only, not for dispensing or flow control. In other words, you can't have this on the wall and people open and close a gate valve to get water out there. It is for isolating purposes only. Then point B says, ball valves that comply with the requirements of 10563, which is the ball cocks that we started off with. Reduced bore valves shall not be used as inline isolating valves, only as servicing valves for terminal fittings. We've all seen these fittings all over the place. They are considered servicing valves. There's a standard for them. Actually need to comply with that standard, but the point is, as far as supply goes, it is only a service valve. You can see this gentleman missed the whole trick here, and that ended up being the shutoff to the actual unit. Considering the rest of the plumbing was done in polycop and another couple of nasties, smaller pipes and all the rest of that, I can understand why I missed it. On this point, when we're looking at reduced bore valves, here we've got a couple of examples. I'd like for you to consider the following. This is actually to scale. So if you look at a 22 mil pipe, the internal diameter on that pipe is around 19 millimeters. So if we're looking at the cross section of water in that different types of pipe, there you can see the area of that water pipe there is pi times radius square. So we end up with 284 millimeters worth of water in, or square millimeters of surface area of that water. So if we do the same thing with a 15 mil pipe, you'll find that there's about 12 millimeters worth of water surface in there, and you can see you end up with 113 square millimeters. So you can see, theoretically speaking, 2 half-inch pipes don't even make up a 3/4 pipe. Now, if we take, and I'm being generous here if I say 8 millimeters, if we take those reduced bore valves, and they've got an 8 millimeter hole in them, and you end up seeing that there's only 50 square millimeters worth of water surface in that cross section where that 8 millimeter hole is. And you can see that's not even half of what a 15 millimeter pipe would carry in it. And if we really need to go that step further and we go, okay, let's be even more generous and we call those reduced bore valves at a 10 millimeter hole, you'll find that it only goes up to 79 square millimeters, which is about 70% of a half-inch pipe. So if you are already under supplying a unit or an installation with a 15 millimeter pipe and you end up putting a reduced bore valve as a flow control, you can see you're cutting down to about, or you're losing 30% just on that hole from being a small pipe already. So if you take the numbers here, you can see there's a huge difference when it comes to size. So when the standard says that we need to make sure we don't use the reduced bores and we only use full bore valves, then that would be the main reason why. So just bear this in mind. I know it's a bit of useless information, but if you consider the size and you consider the actual the cross section, it affects volumes, it affects flow rates, it affects noise. There are various factors that come into play, but when you look at these numbers here, you can see it's quite clear why the standard says that you shouldn't be using any of those fittings. Then the last thing around these valves, shall not be used to control flow rate of water, as this would cause damage to the seats of the valves, which in high pressure systems could be of a serious nature. You just look at these pictures here, the whole design around the gate valve is that it is beveled towards that slot and it fits in there tight. So now you end up leaving it half open, and you'll find that the water would find a way to wire draw these gates and the seats for that matter. So you can see in both of these cases here. There you can see that's where the water is forcing its way through there. So this gets damaged, the seat and the gate itself. So you can see that's been corroded there. It takes an absolute pounding. So next time you need to do something small or you need to have the water shut down completely, you'll find that that is more than likely going to, it's going to be a nuisance. It's going to have this continuous drip, simply because someone used it for flow control instead of rather shut or fully open. So even if you're doing maintenance on these older buildings and you do run into these valves, make sure that when you leave turn them fully open or fully shut. Don't leave them halfway there, because the moment the water gets hold of it, they do take a pounding. Okay, that's my bit for the morning. Have we got any questions?
Yes, we have two quick questions here.
Okay.
Or not two questions. The first one, why do they make an anti-clog gate valve and a clockwise closing gate valve?
That was before my time. What I can tell you is that we have been, well, I say we, the local authorities have been replacing by attrition. So when these valves do go, or they do end up giving hassles, they do end up being replaced with a normal clockwise one. So I'm not 100% sure about the anti-clockwise. I know they're around and I know they're a huge nuisance, but I wouldn't be able to tell you why. I'll have a look at that. So if you leave your details on the system, I'll get back to you.
Okay, and then the next one, hi, is it required to install a backflow preventer on a new domestic property?
On a domestic property, I would no. There are, in SANS 10252, there's a number of places where you do require backflow prevention. Those would be, well, there are two types of applications. You either go for the building itself, in other words, the places where you do have to put them. That would be if you're looking at uses, or what do they call them? Occupations. There we go. A general installation serving the following activities would be medical treatment, medical research, agriculture, laundry, photographic processing, metal plating, or treatments of hides and skins, or an installation serving the following locations: mortuaries, abattoirs, sewage purification, refuse, harbors, oil processing, wineries, sports fields, or any other activity that could pollute your potable water. So your appliances or your fixtures or your sanitary fixtures, if required, they should already have backflow prevention on them. But as far as the actual house or actual residential premise is concerned, no, you do not need them unless there's something in there that would pollute your water.
Does the regulation make provision for a stop valve to HWB? Hello, Adrian, you there? Alright guys, sorry, it seems that we are having some technical difficulties with this internet. See if he comes
Jacques,
back and maybe I'll, there you are, Adrian.
here we go. Sorry, yes.
Okay.
What was
One
that
more
last
question and
question?
then we can, yeah. Does the regulation make provision for a stop valve to HWB?
HWC.
Maybe typing error.
Yes. Yes. If you look at SANS 10254 and you look at the 10252 part 1, if there's water in storage, like a hot water cylinder, you need to be able to isolate individually. You would not want to necessarily shut down the whole house if you need to work on a geyser or the geyser replacement. If you're looking at shutting down water while you're still getting the geyser, getting your fittings and that sorted, you need to have water in the rest of the house. So anything in storage, like I said, cistern, container, water tank, geyser, you actually need to provide separate isolation to each of those entities.
Okay, thank you, Adrian. That is all that we have time for this morning.
Okay, guys, keep safe. For the guys that are out there working, make sure you and your staff stay safe, and we'll chat again.
Thank you, Adrian, and thank you, ladies and gentlemen, for joining us for this morning session. Please remember, on your way out, there is a survey. Take a few seconds, fill that in for us so that we can see how we can maybe improve and how you guys are finding our service. Like Adrian said, stay safe, stay healthy, and then see you guys again next week.